Hey guys, so in module 3 we talked all about slopes, y-intercepts, we put it together with slope-intercept form and graphed it. So now we're going to get to where we only have certain pieces and they want us to write equations. So we have to figure out which method is best. So we have two main methods when writing equations. So first we're going to start off with a couple of examples where we're given a point and a slope. So I want to review what we did on bell work. Actually, go ahead and pause the video. When you go ahead and glue in your stuff, make the body of the notes, make that a flapper because we have another example. So this example, I want you to go ahead and tuck it underneath. Okay? And when you're ready, go ahead and press play again. So we are given a point and a slope. So if they want us to write something in slope-intercept form, we have two methods. We can use slope-intercept form, and we also have an equation called point-slope form that can help us do that. So first, let's review what we did on bell work last week. So let's use our slope-intercept form. So we are given a point, and we are given a slope. So if I put that in slope-intercept form, y equals mx plus b. So first, we have our m, we need our b. So let's go ahead and substitute our values for y and x, and that way we can solve for b. So my y value, 5, so 5 equals, m is 3 times x, so times 7 plus b. All right, so what we got to do is simplify. So 5 equals 21 plus b. And now I'm going to go ahead and subtract my 21. And b equals, what's that, negative 16? Yep. Okay, so we have m, we have b. Now all we have to do is replace. So y equals mx plus b. So 3x. And then we got a negative 16, so minus 16. Okay, so I'd like you to go ahead and try the next one. So pause the video, try the next one, and then come back when you're ready and check your work. Okay, so same thing, I'm plugging into my slope-intercept form. So y equals mx plus b, so my y is a 1/4. Equals, I've got a slope of 11/16. This looks fun. Times x, which is a negative 4, plus b. Okay, so I want to try and make these numbers smaller and easier to work with. So as opposed to multiplying 11 times negative 4, what I'm going to do is I'm going to cross simplify first to make these numbers a little bit easier to work with. Because 4 and 16 are both divisible by 4. So negative 4 divided by 4 gives me a negative 1. 16 divided by 4 gives me 4. All right, so we've got 1/4 equals, okay, 11 times negative 1. So negative 11 over 4 times 1 is 4 plus b. Okay, even though we've got fractions involved, they were nice to us, because if I'm going to add 11/4 to my 1/4, hey, that's okay, because these already have common denominators. So 1/4 plus 11/4, 12/4 equals b. And I know I can simplify that because 12 is divisible by 4. So 12 divided by 4 is 3. So my b term is 3. All right, so that wasn't so bad after all. So y equals, my slope is 11/16 x. Remember, you can either put your x in the middle or in the numerator. If you put it in the denominator, it's no longer linear. And then we add our b. So this time we have a positive 3. All right, fantastic. Hopefully that's what you got. Okay, so I want to throw in a little bit. Oh, wait, sorry. We're going to do this one first, and then I'm going to throw something new at you. So the total monthly cost of Hazel's cable bill increases by $4.99 per movie. Okay, so per movie, there's my rate of change. Per movie she purchases. So it wants us to, all right, we need to write an equation to represent the situation. If after watching 3 movies, her bill is, so equals $93.97. Okay, what's missing? If I know it's $4.99 per movie times 3 movies, that's definitely not $93.97. So, what was the original bill? Oh, wait, come over here. How much is Hazel's bill, base cable bill? So, that's what we're trying to find here. Well, we know if we're renting 3 movies, the total is $93.97. So I'm going to set it equal to $93.97. So it's $4.99 per movie. Now, normally I would say $4.99 but we know we watched 3 movies. So I'm just going to plug in 3. Plus, what am I missing? Well, we don't know what the base price of the cable bill is. So that's what we're trying to find first. What's her base bill? So I'm just going to name it B. All right, so I'm going to get out my calculator. Oh, I don't really have to. 15 minus 3. So $14.97 plus B equals $93.97. Oh man, they're being so nice with these numbers. So we can subtract $14.97 and find that our base price is $79. Okay, so this question kind of had two problems in it. It wants to know, first we had to find how much the base cable bill is because we need to know what's our starting point. Remember, that's your y-intercept. Where do we start? And then from there, we're either going to go up or down. So in this case, we're starting at $79. So if I go to set up my equation, I start with $79. And then I want to write equation, who knows how many movies I buy. So let's put, so our slope, our rate of change, so $4.99. I want to write equation so I can figure out any price. So M, because $4.99 per movie equals C for cost or P for price. Either of those would work. So there's my equation. And that was my base price. So this question kind of had 2 pieces. We had to work backwards, find what our actual base price is, and now we can write an equation to find any price or any cost of our bill. All right, so now I want to talk about something new, and this is called point slope form. So point slope form is just another method that we can use to write equations for something that is linear. Now these are a little bit different. It says write the linear equations given 2 points. So last time we were given a point and a slope. Well, if it's linear, we need at least those 2 things. So what are we missing? We don't have a slope. But we've already learned how to find the slope when given 2 points. So if I have the points -5, 4 and -2, 6, I can find my slope. So using that slope formula, I take my y's. Always identify your y's first. That would make you do your rise over run. So our rise are our y's. So I'd like to do 6 minus 4 Now if I do 6 minus 4, remember this order is important, I must start with my negative 2. So negative 2 minus negative 5. That is where people make a mistake. They just put minus 5. No, what are we subtracting? A negative 5. So don't drop that sign. Alrighty, so 6 minus 4 is 2. And 2 minus negative 5. Keep change. So negative 2 and a positive 5 gives me a positive 3. So I have a slope of 2/3. All right, so now I have a slope. I have my m, and I have either point that I can use. So you can use slope-intercept form. I want to teach you a different method though. So sometimes you're going to use one versus the other. Sometimes if it just tells you to write an equation, you can use whichever one you like best. So if it tells you to put something in point slope form, then you have to use point slope form. If it's telling you to write it in slope intercept, you can use either of these methods. So point slope form, okay, that is y minus y1 equals m times x minus x1. So this is kind of, see how we're using similar format to our slope equation, our y2 minus y1 over x2 minus x1. Okay, so we're going to keep those in mind. So this is just telling us we're using a point. Now, go back to the beginning. We were given 2 points, so you can use either of these points and it will still give you the same answer. So I'm just going to go ahead and use my first point. Since both of them have a negative, doesn't really matter either way. So actually, my slope is 2/3. Nope, I changed my mind. I'm going to use negative 2, 6, just because 6 and 3, that might help me to simplify later. Who knows? So if I plug it into point slope formula, so anything left in black, so my y and my x, those are going to stay. So y minus, okay, so our y1, so my y value is 6, so y minus 6 equals, all right, we found our slope was 2/3 times x minus, and now our x1. So minus a negative 2. All right, so real quick, so I don't mess up something later, I'm going to simplify inside my parentheses and do a little keep change. So I've got y minus 6 equals 2/3 times x plus 2. If you are asked to write something in point slope form, you are done. That is point slope form. Okay? Now, if it wants something in slope intercept form, all we have to do is simplify this. So I can't simplify my parentheses anymore, so I'm going to go ahead and distribute my 2/3. So if I need to keep going, I'm all about solving for y. So I'm just going to bring down my y minus 6. So when I distribute 2/3 times x, 2/3 x, 2/3 times 2, 2 times 2 gives me a positive. Remember, you can put this over 1 if you get confused. So 2 times 2 is 4, 3 times 1 is 3, so plus 4/3. All right, this might get ugly. So get y by itself, I need to add my 6. So if I go to add my 6, can I add 6 to a 4/3? No. So these do not have common denominators. So remember, this is 6 over 1. So to make it have a common denominator of 3, I'm going to multiply by 3 over 3. Remember, 3 divided by 3 is just 1. So all I'm doing is multiplying by 1. But this is going to make me have a common denominator. So 6 times 3, 18 thirds. Ugh, this is yucky. All right. So we got a slope of 2/3 x and a y-intercept of 4 plus 18, so plus 22 thirds. And yep. Oh, that's not my pretty one. (22/3). Can't simplify it. I can just leave it just like that. Okay, so yes, we had a little bit of yucky fractions over here, but we're just simplifying, like that's literally leave it an improper fraction. Now, unless this was like 21 divided by 3 and I could simplify it, then we should simplify. But if not, just leave it. That's fine. All right, now sometimes I want you guys to try point slope form again. So you can either pause the video if you want or go ahead and follow with me. That's fine. I have decimals, so I'm definitely getting out a calculator to make my life a little bit easier. Okay, so again, I'm given 2 points, so I am missing a slope. That is definitely always the first thing I need to find is my slope. So our points are 3.2, negative 1.2, and 1.9, 1.4. Okay. Let me pause this real quick. I need to go find a sticky note because I'm going to write a sticky note off to the side with our steps. Just kidding, it won't let me pause. Okay, so I'm just going to put it off to the side. So you guys go ahead and put these on a sticky note. So when using point slope form, when given 2 points, first thing we do, we have to find the slope. All right, so m equals, so always, always, always change in y over change in x. So identify your y's. So I have a negative 1.2 and a 1.4. So I'd like to do 1.4 minus a negative 1.2. And then divide that by, so I started with 1.4, so I need to start with 1.9 minus 3.2. All right, so I'm going to use keep change, change, and give myself a 2.6 over 1.9 minus 3.2, a negative 1.3. Hey, that's okay. Are those divisible? I feel like that's divisible. 2.6 divided by 1.3. That looks nice. Yes. A negative 2. Awesome. So it looks ugly, but we actually ended up with a pretty slope. Cool. All right, so first, find the slope, and then you have 2 options. So when given 2 points, you can either use slope-intercept form or you can use point-slope form. Now, obviously, if directions say to put something in point-slope form, then we need to use point-slope form. But if it says to put in slope-intercept, you can do either. You can come up here and plug it into slope-intercept form and just plug in your b, or when you get your point-slope form, you just continue simplifying. So that's up to you. So if we're using point slope form, first find your slope, second plug in this formula. Actually, let's pick a point and then plug in a point slope formula. Since we have 2 points, pick either one, then plug point and slope into formula. All right, so if I'm plugging in, which point? I'm going to use the one with all the positives, so I'm going to use 1.9, 1.4. Regardless, I think it's going to be ugly, so I got a calculator. It's all good. So y minus y1, so my y value 1.4 equals m negative 2 times x minus my x value, 1.9. All right. I can't simplify what is inside my parentheses. So if it only wanted us to put into point slope form, we are literally done. Okay. Now, if it wants it into slope intercept form, then we need to keep simplifying to solve for y. So I'm going to take this -2 and distribute. So -2 times x, -2x, -1.9 times 2. Oh wait, negative times the negative becomes positive 3.8. All right, so this isn't really that bad. So y minus 1.4. So I'm going to add my 1.4, get that y by itself. So y equals -2x, and then a 3.8 plus 1.4 gives me a positive 5.2. Okay. So works the same whether we have fractions, decimals, nice whole numbers. It just depends. Sometimes we end up with like a super pretty answer, and sometimes it might get a little bit messy along the way. Biggest thing when you are doing these, follow directions. Does it want slope intercept form or does it want point slope form? Don't do more work than you have to. Okay? All right. You know we need a word problem. So let's look. Ooh. How can we create an equation to estimate future populations? So, the population of young adults ages 14 to 24 in the United States increased during a recent decade. Okay, so it looks like we're going up a little bit. The table shows the number of young adults 5 to 9 years after the beginning of the decade. Write an equation that could be used to predict the number of young adults of if the population continues to grow at the same rate. That is what is key, because same rate is telling me that it is linear. It is growing the same thing every time. Now I'm going to check by looking at my pattern to see if that's true. So 46, okay, so let's see. I'm going to just work backwards. So 46.78 minus 46 and 51 hundredths tells me I'm going up by 0.27. Now remember, it's not 0.27, it's 0.27 millions. So we'd be tacking on some zeros to the end of that. All right, so now that I have a rate of change, I want to make sure it's the same thing every time. So I'm going to take that 0.27, so that 27 hundredths, and I'm going to add it to 46 and 78 hundredths. And that is not 47.05. Oh, goodness. What do we got going on here? Minus 40, 0.19. Uh-oh. 46 point. So I'm taking 47.07, and now I'm subtracting 46.97, 0.1. The population from 4 to 24. How can we create an equation if it's growing at the same rate? Oh, here we start growing at the same rate. All right, so we were changing, I'm assuming since we started growing at the same rate at the end, that's what we're going to use as our slope. So since we're using that as our slope, we have multiple points we can choose from, but I'm going to play it safe. And since this is when we actually started moving at the same rate, I'm going to use one of these points. It doesn't matter either way. So how can we create an equation? I'm going to use, it doesn't specify what kind of equation, whether it wants slope intercept or point slope. I imagine slope intercept, but it's not specific. So let's say we want to put something in slope intercept form. So I'm going to go back and I'm going to use my original y equals mx plus b because I already have an m. So y equals mx plus b. So my y value is that lovely 47 and 7 hundredths. Yay. All right, so we found that slope became constant at the end. So it was going up by 1/10, but remember, that's in millions. And then times x, so in this case is 8 plus b. Remember, you could have used slope-intercept or point-slope form. Both of them are going to give us the same answer. Just this one, it doesn't simplify the answer. We just have to simplify it at the end and take that b and rewrite our equation. So 1/10 times 8 gives us 8/10. So if we subtract that, oh, sorry, not 8/100ths, 8/10. So my b is minus 8/10, 46.27. I wish I had somebody next to me checking my math to make sure this is all right. All right, so I've got a b, I've got an m. Now I just got to write my equation. So y equals, so our slope, 0.1x plus 46 and 27/100ths. Again, this is one option. You could always